Hello everyone, welcome to our webinar. Hira Walraven would like to welcome all of you to the webinar on modular solutions for heavy installations. So we'll be focusing on solutions for all sorts of heavy installation in the construction industry.
Hello everyone, I'd like to welcome you all to our webinar on heavy-duty solutions and specifically to talk about a bit about our Maxx system for heavy load installations. I'd like to ask if everyone can hear me. If no, please type on the question or in the chat box. Everyone, I think we can start. So welcome to our webinar on modular solutions for heavy installations. We will talk a bit about typical installations, typical heavy installations, typical processes to install heavy equipment, heavy piping, and why we believe we have very good solutions. And we'll talk a little bit about that, and I'll show you how you can contact us, how you can get in touch with us to support you on your process of installing any heavy equipment, heavy piping. What can we offer? What is our process of engineering? We'll talk a little bit about all of that. So my name is Bruno. I am a business development manager at Hira Walraven. I have about over 7 years of experience in the construction industry. 4 of them I have been working in construction services. I am specialized in anchor and MEP support system design. I'm also an anchor and installation systems training. My background is in civil and structural engineering. So today I'm projecting something around 60 minutes for this session. The presentation should last about 40 to 45 minutes. Then we'll have the remaining time for questions, which will take 20 to 15 minutes, maybe more if necessary. So I want to try to reply to all of your questions while we are doing the session. If not, I will answer them all by email after the session. Meanwhile, if you have any questions, just type them in the question box or the chat box, and we'll get to it by the end of the presentation. So the content for today, I'll talk about who we are at the company, the Hira Walraven. We'll have a look on the conventional supports to install MEP systems, the advantages that we propose using our Diamond Walraven fixing systems, and some application examples and design cases of projects that we've done before, that we worked in before, and what we propose and what kind of solutions we offer and what kind of problems we solved. So to start with who we are, I'd like first to show you a quick video about our Hira Walraven Academy that we just launched earlier this year. This is a concept for us to share the knowledge that we've created or that we've learned for the past 40 years. We want to spread it out to the industry and to help more people to know about this kind of systems, this kind of installations. And we include webinars such as this, training and coaching sessions, and all kinds of engineering and support services as well. I'll just play it for you. Right, so that was the video. I'll give a little bit more detail about us and about what we've done and where are we located as well. So we are a joint venture company between the UAE-based Hira Industries and the Walraven Group that is based in the Netherlands. And this joint venture was launched in 2015. Hira was founded in 1980, currently has sales companies and manufacturing units in multiple locations across India, Middle East, Africa, Asia, and USA. Currently, we employ more than 1,100 people from more than 20 nationalities. Walraven itself has originated from the metalwork company Diamond Walraven in 1942, so has some decades of experience. Currently has production and sales companies in more than 15 countries, in Europe, Asia, and USA, more than 1,000 employees that work currently for the group, and we have more than 60 patents, something very exciting and something very innovative. This is something that guides us as a company. At a glance, Hira Walraven has manufacturing plants in UAE and India, sales companies, as I said before, Africa, Middle East, India, and Asia, and we are a manufacturer and supplier of complete fixing system solutions from pipe supports to vibration control. We are the only one in the Middle East that offers everything for this kind of industry. Quality is very important for us, so we are ISO certified, we are RAL specified and an MSS member, and we design solutions to meet the most demanding quality standards such as FM, UL, VDS, ETA, and RAL for pipe supports. We offer a vast range of solutions for the construction industry as well that can be placed into different groups. One of them is certified installation systems comprised of pipe supports, channel systems, rooftop support, vibration isolators, seismic design, seismic restraints, sliding devices, fixed points, all of this. Then mechanical and chemical anchors with high performance testing, from concrete screws to through bolts, to high load anchors, to drop-in anchors, and chemical anchors, which are amongst the best performing types of products in the market. We, as a company, how do we help you? So we market our products under the name Diamond Walraven. This is our brand, company Hira Walraven brand Diamond Walraven, and we offer anchor design services. We do field testing, pull-out testing on these anchors to verify the feasibility of the anchor and itself, the base material, if necessary, to verify that the solution is valid. We do tailored and custom solutions for any kind of project, any kind of fixing system, and specifically seismic design for piping, ducting, heavy equipment, everything that needed to be supported from an MEP way, we do that. We have decades of experience in all types of projects. For instance, projects like Dubai Mall, landmark buildings, transportation networks such as Dubai Metro or Riyadh Metro, or different kinds of transportation networks as well. High-rise buildings, so very high towers, we have worked on them, which we know that have certain specifications. And iconic developments such as Expo, which we hope to see coming up to live next year. So our values as a company guides us because we want to be the most preferred brand in this segment. We'll only get there by being the most innovative company in the industry. We want to set the standards, and we want to pioneer new and smart products and techniques. So a large part of this derives from our values, which we value a lot, and that includes to think smart, fair play, to be transparent, very open, very honest, to communicate clearly, have an open communication between ourselves and between our clients and our partners in the industry. We need to be reliable as well. We need to be trustworthy. And we always want to challenge ourselves and, by default, our clients and our partners as well. So this is what guides us as a company. Okay, so that was the introduction. Now I'll start talking a little bit more about what brought us here today. So I will start with a look on conventional supports. So before I start, just allow me this introduction. The first MEP systems, let's say MEP systems, they were built to transport water from our ancient societies. People were very smart, very ingenious, and they always wanted to find ways to transport water wherever they lived. I'm talking about living in the desert or living in the mountains. There was something that always propelled people to find ways to inhabit any region, and one of the most important things was to have a good source of water. So the Roman Empire, for instance, just built aqueducts of masonry. Here in this region, the UAE, we have very old irrigation systems used for agricultural processes and for that kind of use. And of course, we have evolved, and now our solutions involve pipelines, pumping stations that carry the water from spring to the cities. So if our system have evolved, that means that nowadays they require a network of supporting systems, and each discipline and project element has different demands. So of course, architecture and interior design, they want something that can be useful as well as pleasant aesthetically, like exposed installation. They need to be nice to look at, while they need to be functional. The integration of the various systems need to be taken into account, and the effective use of available space is something of high concern as well. For our segment, let's say, so civil, mechanical, electrical, what we need is systems that are very corrosion resistant, that are safe to carry the various components of electrical, plumbing, HVAC, or firefighting, and they need to be easy to integrate between all of these services. And the reduction on non-structural cost greatly impacts the total amount. And why? Because the value of the non-structural elements far outweighs the structural cost. It's crucial to be efficient on all aspects of the construction. I'll show you a couple of things. This one is the relative investment value of a building. The structural part for, let's say, residential commercial is 18 to 20%. So that means that only a fifth of your money worth is going to be for the structural part. So everything that's non-structural, I'm talking about MEP systems, furniture, architectural elements, facades, all of this are part of the non-structural part. So this is something so valuable that we need to be very efficient on installing and on designing these kind of systems. As you see, there are way more non-structural elements in a typical construction than structural. So structural, I would say, beams, floors, roofs. This is what composes the skeleton of a building, but the building is only a building when it has furnishing, equipments, partitions, piping, windows, all of this. So of course, if MEP is very important, it's not a good idea to just not be efficient on this part. As you can see in here, the majority of MEP installation goes to HVAC and electrical. I'm talking about more than 75% goes to HVAC and electrical. So this is where we come in. We want to design and want to supply and want to help our clients and our partners in being more efficient and to increase the return on investment. So if you are more efficient, if it costs less, if it's faster to do, that means you can move on to the next job. You can finish the current job in a much faster way. You can hand it out to the client, and you can get a better return of your time and your investment on all of this. This is what shows approximately as an estimation. This is data from our research and from the market research on what typically costs to do HVAC, electrical, protective, and security systems in a normal building. So typically, when you talk about MEP installations, you talk about heavy or you talk about medium light duty. And what you've been using for the past decades, or what people have been using, are mostly I-beams, L-angles, C-channels. And this is what it's typically used, and this is what I call a traditional supporting system. So beams, of course, they can be used to support piping. Is it a good solution? As you see on the images on the right side, to connect all of these elements, pipe work, and every kind of system to these kind of supporting structures, you need a lot of work. You need to weld, you need to clean, you need to lift them, which is not easy. It costs a lot of resources. And as a general rule, these kind of systems take usually 4 times more to install than what we propose as a better solution for this. And generally, they take more resources. And it is clear why. I'll show you. Conventional systems are much more labor intensive because you need to cut beams at site. This is with heavy tools or torches. Then you need to remove the slag, you need to grind, and you need to perform a lot more finishing work processes and steps. If you want to weld, which is often the case to connect between different elements, there needs to be a surface preparation, and it takes some time, and you need to do a little bit outside of where you actually want to install. So welding, then it takes time and it takes special licenses, and you need to have a concern about safety. You need to grind after welding, and you need to repaint or galvanize. And of course, this is heavy and requires more resources to fix in place. You need more people to either carry or to lift them to place, or you need heavy machinery to support you on this task. So it's not easy to do all of this, and yet you still see a lot of projects where this solution is still being proposed. And we believe in Walraven this is not the best way, or this is not an ideal way to do this. Now, of course, these kind of systems, they have some advantages, and one of them, or the main one, is that they are very sturdy. Mechanically, they are amazing. This is something that can carry heavy loads, but it costs a lot, and you have a lot of drawbacks to just consider them. You lose a lot of time on the job. You need specific health, safety and the environment and technical certifications to just perform the welding. Plus, of course, you need to undergo some inspections on the quality of the welding, which also takes time. There's a greater fire hazard, of course, since we are talking about hot work. And you have a lack of flexibility in future expansions or modifications. So if you want to just, in the future, change the type of pipe, or change the piping direction, or even change the diameter of the pipe, it will take a lot more of these steps to be performed again, or even doing it all again. Then high cost in man hours because of all of this. So more energy, more material, more people working. And this is not an efficient way. Then this is what increases the cost of the mechanical systems in a building. So to maximize your return on investment, to cut on project costs, the best solution is modular support systems. Now, they are very common as well as tertiary supporting structures, but this webinar is more geared to consider them as secondary steel structures. So to serve as a support that's being connected to the main structure of the building, being it concrete, being in concrete or being in steel. But something like this, instead of using another beam, another typical beam, or another element, you can consider heavy modular solutions to be secondary structures for your project. Another thing that's much easier to use instead of the traditional ones are for prefabricated assembly. So if you want to speed up your process in the factory floor instead of at site, you can manufacture all of this, and we can do that. We can design and we can fabricate them for your project as well as your demands and your requirements, and as per your need of the specific systems you need to install, the size of ducts, the size of pipes, the equipments, the fans. We can manufacture them at site and then ship it out to you. So this will save you a lot of time as well. Then for heavy pipe work and integration with beam models, it's much easier to use something that we have with our extensive beam library. We have all the models for all this product. It's much easier to then integrate with your project beam model. And by this, you can speed up your installation time approximately 4 times than compared to the traditional systems. So our solution for all of these heavy applications is the Maxx heavy frame modular system. Before I go to that, I'd just like to speak a little bit more on what other solutions we also offer. So we offer our channels for light duty applications, light to medium duty applications, channels for medium to heavy duty applications, and our Maxx heavy rail for heavy duty and industrial applications. So our rapid rail, which is our light duty segment, we offer it in 2718 1.2 size, and this is by standard in pre-galvanized or electro-galvanized finish, which can also will be done in HDG in our Ultra Protect. So the previous webinar that I've spoken about, if you attended, I've spoken a little bit about our BUP system, and stainless steel if necessary. Same goes for our rapid strut, so also electro-galvanized, hot dip galvanized, our Ultra Protect system, and stainless steel, and our Maxx, which is by default HDG. If necessary, we can go a little bit up, if necessary for the project. So our rapid rail, we propose to reduce our installation times in half by using no loose parts. So everything is pre-assembled, and the accessories are pre-assembled as well, and you just need to connect them to the channel itself, to a clamp, then to the pipe, or whatever is necessary to be installed. There's a complete range of rails and accessories, and our rail types can be used on both sides, and this is for light to medium duty installations. Typical installations would be sanitary, some light duty ducting, some light duty piping as well, and this can be connected single piping or multiple piping running side by side. It's very flexible, and this is something that is very common. And instead of just using a normal C channel or a normal angle bar, consider this to speed up your time. Our rapid strut, so for our medium to heavy duty installations, we offer what we call a rapid strut, which is a channel serrated, also with ready to use pre-assembled accessories that is suitable for all profiles. Our rail and cantilever arms have serrated profile for extra grip. It's for medium to heavy duty installations, and we offer them on sizes 41-10-1 all the way up to 41-82 double. This is from 1.5 mm thickness all the way to 2.5 mm thickness. So it depends on the type of requirement and all the type of load that needs to be installed. We then come up with you, we then study it, and we help you choose the right solution for this. But for heavy applications, there's something else. The rapid strut you can use to connect all types of pipes, all types of ducts, all types of equipment. Same as before, it can be used to connect multiple pipes side by side, to connect also a single piping, and to use as it is proposed on these images. For instance, it speeds up your time considerably. Really, there's a huge impact on the installation times that you can see while doing the single drop-in anchor with threaded rod and then pipe. This will take a lot of time, and this can save you quite a lot of resources on your construction project. So now moving on a little bit to the Maxx heavy rail profile. So we offer them in 100 by 100 by 3 and 100 by 120 by 4. So you're talking about a square profile or a rectangular profile. And this is what we offer for heavy applications. I'm talking about heavy pipes, 20-inch, for instance. Think something like this: heavy equipments, heavy chillers, something that needs to be installed, and it's not easy to install, or it will require a lot of support. This is a solution that you can consider. Or when it's something that it's by default to be installed, to be exposed under rough environment conditions. Since this comes by default with HDG finish, this is what we typically propose for this kind of applications. So the Maxx heavy duty profile, it features a closed box profile that's highly resistant to torsion, has continuous perforation on all sides. The standard finish is in HDG with stainless steel available. There's a huge variety of connectors and accessories for easy frame building. And of course, as before, we have an extensive library of 3D models to be quickly integrated with the beam model of the project. So the section itself is quite light. You see, for instance, the 100 by 100, it just weighs about 8 kilos per unit weight. So this is lighter than a typical that you'll see typically as an I-beam of the same kind of dimension. So it's much easier to install, plus has all of the advantages of not being needed to be welded to any other element. You just quickly connect everything in a modular way. Plus, being such a light section is still quite strong. You can see that it can carry all the way to 32 kN, for instance, as a cantilever form. So it's something that's very sturdy as well. So you don't have to worry about if it's going to hold the load that you need, or if it's going to support your equipment. We designed that in a way that it will be able to support, because we have a lot of confidence, and our results and our data and our tests show that this is something to be trusted. So Maxx itself offers a considerable reduction in installation cost, in fixing times, and in man hours. So it's easy to cut to the desired length. It is easy to connect between elements. It is very flexible for future expansions or modification of the system. If it needs to be, you can reuse in an easy way, because you just need to remove what was connected and then reconnect again. It's considerably lighter to handle, And more importantly, it avoids any welding or drilling to connect elements. So the type of work at the factory floor or even at site, it's completely cut off. And there's no need for repainting or galvanization since it's already, the surface is already treated. So there's no need for galvanization, repainting, any grinding, deburring, or slag removal. So it will save a lot of time in these kind of installations. So to sum up the advantages of using the Maxx system, it offers 50% savings in installation times, if not more, with a high productivity on the site, no welding, and of course more handy. It's a lot more safe because since it's lighter, it's easier to carry. You avoid welding, so you reduce hot work risk. And we can offer complete on-site product training and coaching as well. The quality is very consistent. There is no need for third-party inspections for welding. There is no welding certificates, and you will be completely safe using such system. And of course, we provide a high-quality engineering support. We assist in designing and modeling. We assist in any technical advice, and throughout the project, we offer continuous technical support. So before I was talking a little bit more, or I was talking why this is something specifically used for outdoor installations, and this is because it features a high corrosion resistant performance. Because by standard, since it comes with hot dip galvanization, it will last to when exposed to rough outside conditions. It can last for a great number of years without any consideration of life expectancy, or if it's going to rust, or if it's going to fail after some time when exposed to rain or in an industrial setting. This is something that's very resistant to that kind of conditions. So hot dip galvanization, this is a process that we apply zinc to the steel by immersing it in a zinc bath. By doing so, a thick zinc layer is applied to the entire product. So you will see it's not something that you'll have less zinc in one part and another and more zinc in another. No, this is something very continuous and very uniform. The Maxx itself has a coating thickness of at least 75 microns. So it's suitable for high corrosion environmental conditions, and when exposed to rough weather conditions as well, it will resist for a long period of time. And this is then used for all elements designed for outdoor applications. So this is something for you to have an idea of what kind of conditions I'm talking about. So typically, hot dip galvanized can be used in C3 to C4 corrosivity categories levels. So we're talking about medium to high corrosion levels. And an idea of the typical environments that this is used for in indoor spaces. These are going to be spaces with high frequency of condensation and high pollution for production processes. So if you think about chemical industries, even in the outside, they are quite aggressive to the support systems. And by hot dipping or by using our BOP system, we can control that damage that corrosion causes. In outdoor environments, you'd see something like urban and industrial atmospheres, or even temperate zones with high pollution. Coastal areas without saltwater spray or without complete immersion in salt water, but with still some exposure to that. This is where HDG can be used, and this is where we typically use this kind of system. And whenever it's needed something else, then we will study, and then we offer something else, such as stainless steel. So to get some context out of this is a graph that shows the coating life to first maintenance, considering C1, C2, C3, and above the conditions. And you'll see around in the middle mark between 70 and 80. So we're talking about 20, 25 years, even more, sometimes depending on the actual condition of that site, by using this kind of product. Depending on the condition, if it progresses to something heavier, or if you expect something different, then it needs to be studied and then it needs to be verified. But as a rule of thumb, this is something to consider. So by using this kind of product, you'll be safe in any outdoor installation. So to rough it up, so the advantages of using the Maxx system, this is suitable for multiple environmental exposure conditions. In this picture here, this was a project that we've done in an industrial setting to be placed outside to support heavy piping. So one thing that was needed, of course, was a heavy or a heavy corrosion resistant properties. And since the pipes were also very heavy to be installed, it needed to be something with an industrial level of strength. So in this solution, or in this kind of case, this is what we go with. We go with Maxx. We don't. We believe this is the best solution for that, and then we can couple it with the rest of the systems if necessary. And this case was necessary. So this is what kind of solution that we can offer in your project. Of course, it's not only that. Since the Maxx system is so flexible and adaptable, you can be very creative in the kind of structures that you need to do. One of them, for instance, on the left, it was a bridge that we've designed to span around 21 meters of span between installations in an industrial setting, and it needed to support cable trays, piping, and so on and so forth of all these systems. And the best way to do it was to use a system that is highly capable of supporting heavy loads. Another example of heavy load supporting is chill water pipe risers for high-rise towers. Those cause, on the fixed points and on the sliding points, it causes a lot of stress, causes huge reactions, and because of that, the traditional way to install this, it's not the best way, because you cannot really control any kind of movement and the actual stresses that it causes on the structure. So we go with what we believe is the best solution, which is, again, using our Maxx system. Even more challenging designs are possible if you think of very complex structures. If you were to do what you see on the right, if you were to do this with normal I-beams or C-beams or U profiles, it will take you forever to just design and to just prepare this kind of structure. So with this kind of system, with Maxx, with our modular solutions, you can actually install much more than you ever think. This was for an automobile factory, and this was then designed to support all the pipes that were needed to be supported in just one structure that was supported on the main steel structure of the building. So this is something that we can do. This is something that we do. This is where we are very experienced in building this kind of solutions. And with our kind of system that it's continuously perforated on all sides, you can connect all kinds of elements and thus be able to create such structures. Now, to connect elements with our Maxx, in our Maxx system, we have what we call the Maxx hammer fix, which is something that enables to connect every element in just 3 steps. So you just need to insert. This is a special bolt that you connect between the main support, the main Maxx system, plus all the other elements that are going to be attached to it. You just need to insert, turn a quarter of stroke, and then attach with another nut. That's something so easy. So if you were considering how to install something in the middle of the channel that you cannot reach inside, this is the solution to do that. And of course, the system is then compatible with any concrete and steel connections. In concrete, we connect the system to wall plates. You connect the profile directly to the wall plate, and then you use heavy load anchors, through bolt anchors, chemical anchors, any anchor that you need depending on the actual application to install. Or if you're going to install 2 steel girders or steel beams, we offer beam clamps as well that can easily be used to attach the Maxx profile to the existing steel structure. As an example here, this is an inclined. We're talking, I believe it was 25, 26 degrees of the actual structure that was inclined, and every MEP system needed to be connected to that, and it needed to be connected in a safe way, and it needed to be to last for a long time. So our solution with this was to use several elements to connect to the Maxx. So we use our support channels, we used our flat washers, our slide nuts, we use our plates as well to connect, and then the beam clamp, as I shown before. This is how it would be used. So other typical installations are normal ceiling installed frame supports, which is something very common for this kind of system as well. In this case, one can use through bolt anchor to connect the wall plate, then a wall plate, then the Maxx bolt set to connect the element to the wall plate itself, and then do all the elements using the hammer fixes as shown before, then the connectors such as the 90-degree connector, which is a part of our range of accessories. Then again, bolt sets to connect all of these elements. And this you can prepare all of this in about 10 minutes. If you compare this with preparing in a traditional way with I-beams, it will take maybe 1 hour with all the welding necessary and all the carrying. It will take a lot of time. With this, you can do in 10-20 minutes. It's something so fast and something so easier that you will instead of building 1, you build 4. That's basically what we're talking about. For flown mounted, it's pretty much the same thing, just inverted instead of sealing, but the elements are going to be the same kind of thing. But this is something that's also very typical for heavy piping in machine rooms and plant rooms, using also the hammer fix, the connectors, and the wall plates. So riser pipes, as I was showing before, this is another example of a riser pipe. In this case, this is a fixed point. The other one I was showing with springs, this is to allow the thermal movement of the pipe. So this kind of supports, this kind of risers, the kind of pipes, they are by nature they are very large. So they, when filled with water, they cause huge reactions on the support. And for this kind of application, the safest way to go is always with something that's very sturdy, so something that's very mechanically strong, such as our heavy-duty system. In this case, you would use our Maxx, then our wall plate, then connected to the concrete wall with through bolts, so with our ETA-approved anchors or any chemical anchor that's suitable for this kind of application, depending on the actual reaction, the actual reaction values. And thus designing this, we guarantee a long-lasting life of service and a safe connection to the riser pipe. Is there any questions that you want to pose now, or if you want to wait until the end of the webinar? Because now I'm going to show some more application examples and design cases. But if you have any questions about what I've shown before, feel free to post them. Then I'll take a look at that. Then I'll try to answer all of them. And if I don't answer anything, I'll just get back to you by email. So to sum it up, so the installations, have you seen, are done better when done with Maxx, because it's very easy to install and saves a lot of fixing time. It's fully compatible with the other systems, and it avoids welding risks. This is typically used for high elevation installations or when there's a considerable span between supports, for industrial and high corrosive environment, and for heavy load equipment and pipes. This is what is typically considered when we think about where we're going to use this kind of system. These are the 3 main factors when you think, okay, this is where Maxx fits best, is when we need to bridge a large span, when the environment is very corrosive, and there's a heavy load equipment to be supported. So how do we do it? We propose the solution and we verify the solution using finite element method software. We don't just do it by hand, so we do it in a proper way. We study and we check the system feasibility. We test the section stresses. We check the moments, the reaction, and the displacements. And as well, we verify the connection between frame elements, which is very important. This is often the weakest link, is a proper verification of the connection between elements. This is where one needs to be completely sure, especially if you're talking about very large spans. If you're talking about something that you need to connect channels between one another to bridge a large span, this is something that's very important for us. And this is how our process of doing this kind of designs. After we studied and we reached to a safe solution, we just model everything in 3D. We then convert it to something that can be integrated with the BIM model, and then we give all of this to you, including the assembly parts, exact material quantity, the lengths, and all of the documentation associated. So you get all of this, and it will make your installation quicker. So even on the installation part, we'll just we'll coach the teams that are going to install. We'll inspect if everything is being done properly, and we try to help you on this. So some application and examples of what we've done in the past and in the present. For example, heavy equipment and ducts on outdoor installations and industrial settings to support large spans and huge length of ducts. This is where we would consider to use our Maxx system as shown here in the pictures. Another example will be to support heavy industrial equipment. In this case, in this picture, the concern was, first of all, that this machine will need to be elevated at about 6 meters of height, and there needed to be a lot of clearing downstairs for the operator to just reach to some equipment that was going to be placed beneath it. So if you were to consider this with a typical or a traditional system, it will take a lot of space. It will take a lot of time to manufacture as well, and then you'll have to galvanize everything because this is installed inside an industrial plant. So all of these considerations were thought of to come up with a solution of using Maxx. Then in this way, it was very easy to design, very easy to install, and we can guarantee a high service life as well. Other examples are industrial piping inside high humidity rooms as well. In this case, condensation plants, or where the machines for a factory are running. All these pipes are typically very heavy. So if you were to use, again, something like an I-beam, it will take up more space for you. And then when you needed to change the layout of the piping, it will take then again a lot of time for you to do it. So to use modular solutions in situations like this is the most efficient way. Plus, it's very easy to connect between everything. You can see on the picture on the right, some clamps as well are connected directly to the Maxx channel. So this is quick and easy to install. To support heavy piping as well, and to support straight from either concrete walls or steel structures, this is where typically you would see the need of using a heavy modular system to support these kind of loads. Fixed points, I was saying before, on the risers, but fixed points can also be on horizontal pipes. In this situation, this was a fixed point for a number of parallel pipes, and they are installed always outside. They are installed outside, so they are constantly being exposed to rain, being exposed to snow. They are exposed to heating and freezing cycles as well. So usually it taxes a lot the system on the corrosion level. So in this situation, we use a mix of our Maxx and our BOP systems, our fixed consoles to support this. This is an example of how the system can be connected between all of the elements and all the different systems that we propose. All of that can be connected, all of that can be used to give a solution. For even heavier fixed points, this is an example of a 120 kilonewton fixed point. This is where we can also do to make this system to be very flexible and very usable as well. This is another example. System compatibility, this was also inside an industrial plant. As you can see, especially on the right picture, you can see that the pipes, they have a tendency of expanding and contracting. So we needed to allow the pipe to move. And the best way that we found to install this was to use the Walraven Maxx as a main frame of support, then using some cantilever arms, and then the sliding devices on top of that. So this is this is an example of how the system can be compatible between each other, how it can connect between each other. And this is the kind of solution they can expect when we work with you. For rooftops as well, which is something that we are going to do a targeted or a specific session on this kind of installations. I just want to give you some examples as well, because this is where we use our rooftop supports with our Maxx system as well, because we were installing heavy equipment, heavy chillers, heavy duct as well. This is where it can be used to do this kind of frames and to be installed outside. Again, considering the corrosion problems and the dangers that it causes, this is where we want to use the best solution that we have. In this situation, we would use our Maxx as a main frame, and we would use our BOP system as a supporting structure as well, on this case, to support the chiller itself or the machine or the equipment. So this is the types of solution that we are able to do with our system that can be easily integrated between one another. Another example of that, another example of the frames. And I'll want to show you now an actual case that we've done quite recently here in the UAE. And this is a multi-purpose arena that is now being finished, if it's not yet completely finished. And some of the concerns or some of the consideration that you had to take into account is that it's built near the ocean, so then there's a considerable need of corrosion prevention. Then all systems, MEP, fire and life safety, interiors, any system needed to be supported from the main steel structure. And the MEP installation followed a very fast schedule, so quick fixing times were crucial. So the idea was at the beginning to use traditional system because since the structure is already composed of I-beams and H-beams, there was mainly the first idea was to extend that structure to a secondary structure built of the same elements in a different size, and then do all of the process of fixing those connections and then fixing everything. And the concern was it will take too much time to install everything. Plus, with all the extra work, they will need a bigger labor force, and there needed to be a different solution, and that's where we came in. So the structural geometry had some considerable challenges for this one. So it was a steel structure with different relative elevation between girders and inclined roof beams. The span between main beams was considerably large. In this case, or in some points, it was reaching up to 9 meters. And there was a limitation on accessibility to the upper beams for installation works because the work deck, it was restricted to a certain load. So even machinery could not go all the way up to support. So there was no easy way to do with the system that was originally designed or originally proposed. So we studied very in depth to come up with a better solution for this kind of process or this kind of structure. Then, for fire and life safety equipments and piping, the NFPA 13 specifies massive design loads on the firefighting supports. And of course, there's highly regulated structural safety patterns that we tend to follow with the deflections that are admissible, with the stress as well. So this solution needed or was calling for something of an industrial kind of characteristics. So NFPA, just to give you a highlight if you don't recall exactly, NFPA demands that the supports be designed considering the pipe filled with water, then considering this weight multiplied by 5, and then 250 pounds or approximately 114 kilos on each support. So if we're talking about a 9-meter span between supports, and then you have multiple supports in between to support the pipe, because you cannot just use pipe support on 9 meters, you need to support them every 1.5 or 2 meters or 3 meters, depending on the pipe. So each support needed to have this into consideration. That means that the design loads were massive. So considering that there was a limitation on accessibility, considering that you needed something that was corrosion resistant, the logical solution for this, of course, after verification, it became even more logical. But the logical conclusion for this was to use modular solution, and in this case, Maxx. So the zones with 9 meters between supports, they required rigidity coupled with lightness to comply to code. And there was no easy way to install because the girders and the beams were at different heights. So if you wanted to keep this at the horizontal level, we needed to be creative as well. In this situation, what we use different levels of Maxx and different connections between each other to then be able to come up with a structure that could support the ducting and the firefighting pipes and the chill water pipes. And because of the way that everything was installed, we need to consider multiple services being supported from the same kind of structure. So this is where we become very creative, but this is the kind of solutions that we can offer in your projects as well. Then, because we're using our Maxx systems, we were able to fully integrate and quickly integrate with the existing beam models of the project. In this situation, you can see on the right side, this is what we've done after we got the model from the structural engineers and the MEP engineers from this project. We then modeled everything, and then we inserted everything so we could check the clashes and everything and predict if there's going to be any issues when installing. and preparing everything. This is the kind of solutions that we offer. We try to go with a full one-stop solution from design to actual installation and coaching. We kept continuous assistance during the project, and during the installation we kept on inspecting, we kept on training the teams, we kept on seeing exactly what were they doing wrong and what were they doing right, so we could help and we can guide them as well. So we don't just do the work and give it up to you and hand it up to you and then it's up to you. No, we give this kind of support, and we feel it's very important to give. So the final product would look something like this. So you could see several cable trays installed, several ducts, several pipes as well, specifically firefighting pipes as well. You can see the Maxx, our Maxx channels used as secondary steel support, steel structure connected directly to the main steel structure of the building, and then everything directly attached from it. As an example here, the firefighting supports, and on the right side, firefighting supports and duct, and every MAP systems were designed to this, were supported from our Maxx system. Thank you for attending. I'll now move on to the questions. I'll now ask my colleague, Fatima, to help me on this.
We have a few questions. I'll start with Fuad. Can we see example of Revit model of your support system?
Yes, Mr. Fuad. I believe, I'm not sure if I'm saying your name right or no, but I hope so. Yes, I show you some examples, and I can reply to you directly and give you some more examples of the Revit model of our support system.
We now have a question from Omar Naeem. Do we have connector available to connect Maxx profile with rapid strut channel at 90-degree angle?
Yes, we do have connectors. We do have connectors available to connect Maxx profile with rapid strut channel. Yes, we do have. I believe on the hand some of these connectors, but every other connector that you can use with a normal rapid strut system, you can also use on the Maxx, because it will be installed in the same way that you would use directly to rapid strut. So the system components are very interchangeable.
What type of connectors will be in use for bracing the Maxx profile in a diagonal?
All right, so the type of connectors to use in diagonal installations would be something that swivels. This is the most important thing. We have a swivel connector. So from that point on, you can either connect directly a thread rod, for instance, or as the example I shown before, and I can go a little bit. Let me just go back. It's all the way back. But this was one of the first examples I've shown here. You can see the connection here was directly with a bolt, Maxx bolt set and the plate. And this was a connector between the Maxx itself and another strut channel.
Another question from Muhammad Hamid. Is this system certified by third party, which guarantees the safety concern?
That's a very good question. Yes, these systems are tested extensively by third parties, both locally and internationally. And moreover, we at Walraven, we are a member and a founder of the RAL system, which is then verified by the German Institute of Quality. So all of these systems that I talked today, they are verified both here and in Europe, more specifically in Germany. So not only the actual design process of how we design this and what is the admissible load, admissible stress, and admissible deflection. Not only that, but the system itself and the material itself is tested and verified. Thanks for the question.
Do we have any further questions? If there are any questions, you can type it down in the questions column so that we can answer it for you. We have a question from Anujit Shetty. In one of the projects, you mentioned that the I-beams were at interval of 9 meters. In such case, when running the channels in between I sections and after loading the surfaces, how are the sagging taken care of?
Thanks for the question, Mr. Anujit. By sagging, I believe you are talking about the deflection, I believe. Correct me if I'm wrong, but if this is the case, when we designed this, let me just go back to it while I've shown the project. This is a fairly good question. Thank you. So when you see here, we were connecting the channel, the Maxx channel, the main Maxx channel, to a secondary Maxx channel that was working as a support. So in this situation, we also designed this, irrespective of the length, we designed this up to an admissible stress and deflection as well. So this sagging and this deflection were taken care of prior to the actual installation part. So we designed this considering that we could only allow this kind of stress and this kind of deflection, and only when it verified that, irregardless of the way that actually the geometry went after and the actual installation process, irregardless of that, when we were modeling it, we verified that deflection. And once it passes, that's when we said the design was okay. So some of the cases that we were trying to design were not admissible. So we had to increase the number of supports to support certain load or a certain pipe or certain duct or whatever was necessary to be supported. And only it passes all those criteria. That's when we deemed it safe.
We have a question from Mohammed Hamid. Can you share the presentation for further reference? I think I would like to answer that. The presentation, along with the video, will be posted on our official YouTube channel. And for your reference, there are 2 handouts attached under the handouts tab for heavy frame modular support as well as Anchor's brochure. You can download either for your reference. Does anyone have any more questions?
Thank you all for your questions. If you think about some of the questions that you didn't remember to pose now, you can get in touch with me at bruno.s@hirawalraven.com or at academy@hirawalraven.com as well. So if you remember, after thinking a little bit more, if you pose any questions, just type me an email. I'll get back to you. Thank you all for attending. It was very pleasant to interact with all of you. I hope this session was informative. We hope to hear more from you in our next sessions as well. We are planning another one geared to the rooftop supports that I mentioned a bit before. So we're going to have several more sessions such as this. We hope to see you next time. And thank you so much for attending this session.